Welcome back to The Explainer. On this show, we take complex, high-stakes source material and just completely break it down. And today, we're unpacking the blueprint of a highly specialized, absolutely fascinating career in heavy engineering. We're looking at the invisible minds who orchestrate the technology that runs our modern industrial world.
Okay, let's dive right into this by asking a massive question. When you picture a sprawling chemical plant or a massive oil refinery, you've got millions of gallons of volatile fluids moving at intense, dangerous pressures. So who exactly controls that chaos? Who acts as the central nervous system to ensure everything operates flawlessly and, most importantly, safely, day in and day out?
Well, the answer lies in a very specific, highly technical role within the Process and Modules division of ISGEC Heavy Engineering. Specifically, we're looking at their Noida-based Senior Instrument and Control Engineer position. And let me tell you, this isn't just a regular job title. It is a master architect role. You are literally responsible for the sensory and nervous system of an entire industrial plant. So let's look at the foundational building blocks required to actually step into these shoes. To become the brain behind the brawn of a plant, you obviously need a rock-solid foundation. This requires a Bachelor of Engineering or Technology, specifically in instrumentation or electronics. This is the table stakes where the core math, the physics, and the complex electronics theory are cemented. You really have to understand how signals are processed on a microscopic level before you can apply them to a massive steel pipeline.
But, as you might guess, a degree alone absolutely won't cut it. Stepping into the senior role demands 8 to 12 years of hardcore, hands-on experience in the field. We are talking about nearly a decade of battle-tested engineering, because you don't just walk out of university and design the control systems for a power plant. You need to have seen how those theoretical designs actually behave in the real, highly unpredictable world over many, many years.
And here is exactly why that decade of experience is absolutely crucial. A senior engineer must build an encyclopedic knowledge of critical safety and engineering standards. We're looking at the ISA, the American Petroleum Institute, and the ASME standards. Now, these aren't just casual guidelines. They are the literal DNA of industrial safety. You have to know these codes backward and forward to ensure every single design is compliant and inherently safe.
Beyond the standard software, a senior engineer relies heavily on a specialized powerhouse program called AVEVA E&I. This acts as your primary digital toolkit. You can think of it as the ultimate digital canvas, where the plant's entire nervous system is drafted, mapped out, and stress-tested, long before a single physical cable is ever laid in the ground. This tool is essentially the command center for managing a truly overwhelming amount of data. You're managing massive instrument databases, you're mapping out thousands of complex connections in cable schedules, and generating intricate loop and wiring diagrams. Without this level of indexing and documentation, trying to build a process plant would be like trying to assemble a million-piece puzzle without the picture on the box. It would be total chaos.
So let's move to the actual engineering responsibilities and see how this all builds from the very first phase of a client project. We're transitioning from the digital tools into the actual workflow. How does a senior instrument and control engineer actually start designing this massive industrial nervous system from the ground up?
Well, it all kicks off with what's called the ITB, or the Invitation to Bid Review. Before drawing a single diagram, you have to follow an exact chronological sequence to translate a customer's tender into a manageable technical scope. You're reviewing these massive tender documents, analyzing the true scope of the project, pinpointing the specific engineering requirements, and vitally, preparing technical clarifications. It's all about catching the discrepancies in the client's request before execution even begins.
And the crucial responsibility here is constantly bridging the gap between the digital and the physical. On one side, you're designing the digital brains, the process control systems and the PLC or DCS interfaces. But on the other side, you're mapping out the physical infrastructure. Where do the instrument layouts actually go? Where do the junction boxes mounted? What's the exact routing of the cables? You are literally connecting the mind to the muscle of the plant. To bridge that gap seamlessly, you'll prepare an exhaustive suite of detailed engineering documents. This is your engineering arsenal right here. We're talking instrument data sheets, block diagrams, loop diagrams, hookup drawings. Every single wire, every sensor, every minor connection is meticulously documented. These documents serve as the undisputed master blueprint that the construction teams out in the field will follow to the exact letter. Okay, so after spending months designing the brain and mapping the infrastructure, you have to actually source the physical parts. That brings us to the execution phase. Transitioning from digital blueprints to physical hardware is where theory finally meets reality. It's where a senior engineer's expertise really gets put to the test.
This is where you select the vast array of field instruments, which are the literal sensory organs of the plant. Everything from your standard pressure and temperature transmitters all the way up to incredibly complex gas analyzers. If the control system is the brain, these instruments are the eyes, the ears, and the fingertips. And choosing the exact right instrument for a highly specific chemical or temperature environment is a critical responsibility. And of course, you can't build a plant without the parts. So creating highly accurate bills of materials, or BOMs, and material requisitions ensures that the precise project components actually get ordered. You have to estimate massive material quantities and coordinate directly with procurement teams. A single decimal point error here, that could literally mean millions of dollars in the wrong materials showing up to a construction site. No pressure, right? But remember, as the master architect, you aren't just managing wires and valves. You are managing human networks. You are rigorously reviewing vendor documents, approving technical drawings submitted by outside suppliers, and resolving really complex technical queries on the fly. You have to hold subcontractors to strict project timelines and absolute quality standards. If a vendor's part doesn't meet those API or ASME standards we talked about earlier, it is solely your job to catch it. Now, at ISGEC specifically, your expertise will be applied directly to specialized delivery units called skids and modules. This means managing the instrumentation engineering for highly compact, self-contained process skids, modular units, and packaged equipment, specifically designed for the oil and gas and chemical process industries. Honestly, it requires an incredible amount of spatial awareness to fit world-class control systems into these incredibly dense modular packages. Bringing this massive scale of design, procurement, and human management together requires a very specific type of professional. The ideal candidate profile outlined by ISGEC is a battle-tested veteran of large-scale EPC projects. That stands for engineering, procurement, and construction. They need someone who understands not just how a single sensor works, but how entire industrial ecosystems are funded, sourced, and built from absolute scratch. If you have spent a decade in heavy EPC projects across these specific sectors, like oil and gas, petrochemical, power plants, or industrial automation, you possess the exact contextual background they are looking for. These industries operate with absolutely zero margin for error, and that is precisely the mindset required to step into the senior instrument and control engineer role at ISGEC. So, we have broken down the anatomy of this master architect. You've seen the rigorous standards required, the software used, and the hardware procured. If your background aligns with this immense scope, perhaps you're the mind meant to design the industrial nervous systems of tomorrow. You can apply via the email on screen or check out their website. But it leaves the rest of us with a fascinating question. As artificial intelligence and automation continue to rapidly evolve, how exactly will the role of this human central nervous system adapt in the smart plants of the future? Something to think about. Thanks for joining us on this explainer.